And we're back. So determine if the triangles are similar. If they are, write a similarity statement. Okay. So this is a little more confusing because now my shapes are they're kind of combined. They're next to each other. But if I look here, triangle DAB is this one. And triangle CAD is this one. So are they similar? Well, do they have all the same angles? Well, they both have a 90-degree angle. That's right here. And this angle here, like that kind of tells you this little that little mark on the angle tells you that these are the same angle. So I can write like angle ADC equals angle AD. It's congruent to angle ADB because they're both 90. BAD is congruent to angle CAD. That's certainly true because that little mark tells me. And because these are triangles, if two of the angles are the same, then the third one has to be the same. So I could say angle ABD congruent to angle ACD. So these are definitely similar triangles. And the similarity statement, I got to make sure that I do this in the right order. I could say triangle ADB is similar to triangle ABC. And there's more than one order for these. I just chose this one. We could have said BAD and CAD, but like the A has corresponded to A and D has corresponded to D for sure, because those angles are the same in both of them. And then B and C are the same. So actually, the way that's drawn is more like this. It's like these two are the same. So I got this angle is the same in both, this angle is the same in both, and the right angle is the same in both, so they are similar. This one's a little trickier because I'm like this small one in here and the whole thing, are those the same? Well, let's see, angle AED and angle ABC are the same because they're marked. ABC. And angle A is the same in both of them. Angle A is in both of them. So I can call that like EAD maybe. See, E corresponds to B. So EAD and BAC. So that's good. But like, do I know if, I guess the question is, do I know if ADE is the same as ACB? The answer is I don't know if it is or not, but actually I do know. It has to be because if this angle is the same in both and A is the same in both, then this one has to be the same as this one. That's just how triangles work. All three angles have to add up to 180. So if like, let me do it with colors maybe. So I got the red angle is the same in both because I was told that. This angle is the same in both because it's angle A in both. So if red and green and blue add up to 180, then red and green and blue have to add up to 180. There's like no other way to do this. And this kind of tells me, using these colors, that I have A corresponding to A, B corresponding to B, and C corresponding to D. And so I can write a similarity statement that way. I can say triangle AEC. So I had a triangle ABB. Is that right? E and B, yeah. And so I've got a similarity statement that way. So it's kind of, the angles are probably the easiest way to do these. We have no idea what these side lengths are. So it's usually smart to look at the triangles and use the angles to find similarity statements. DE is parallel to BC. Okay. So, right. So I have two triangles here, ADE and ABC. So I'm going to redraw them over here so that I can kind of look at them separately. Let's say that's ADE. And let's say this. I really went ham on that thing. I don't know why that's so angly. ADE is right here, and ABC is the bigger one. And I chose that because I know that those are the two similar triangles, but there's kind of some thoughts with this. Like if these two lines are parallel, then this angle, let me give with colors. This angle has to be equal to this one. That's something we know from geometry, hopefully. And by the same rationale, this angle has to be equal to this one. And this angle is the same in both triangles. So I got a blue angle in both. I got a red angle in both. And I got a green angle in both. So to identify any similar triangles is to like write the similarity statement. ADE is congruent to ABC. And it's kind of nice. The way I drew these, it's easy to see which angles correspond. And it says find X. So maybe I should label the sides here. A side AB is 3. Side AE is 5. Side AB, which is this side, is 3 plus 1. So that's 4. And side AC is 5 plus X. And now I can write my similarity statement. I know if these triangles are similar that AD over AB, that's not an A. AD over AB, this side over that side, must be equal to AE over AC. Again, I'm just writing the ratios of the corresponding sides. AD and AB are corresponding, and AE and AC are corresponding. And I know what all these, well, I know what most of these lengths are. AD is 3, AB is 4, AE is 5, and AC is 5 plus X. Now I can do a little math here. Some people would be like, cross multiply. Okay, 4 times 5 is 20. 3 times 5 plus X is 15 plus 3X. So 5 equals 3X. Jeez, I'm really bad at that. 5 is equal to 3X, which means X equals 5 over 3. So I identified the similar triangles and I found X. And it's all about the ratios of the sides. You don't always have to pull these triangles apart like that, but I think sometimes it's easier to see the corresponding sides if you do it. Again, not necessary, but sometimes it's handy. Identify the similar triangles. I'm going to leave this one. If y'all want to try this one on your own, you're welcome to do so. It doesn't actually matter whether you find X or Y first. I'm going to leave this one. I'm going to talk about this as it's quadrilateral. It's a little different. Quadrilaterals below are similar. Find the values of X, Y, and Z. So I can see that like I have this little guy here, sides are X, Y, Z, and 10. I have this triangle here. I got 15, 16, 12, and this whole side appears to be 24. So the corresponding side to X is 15. So I can write X over 15 equals. The corresponding side to Y is 16. Equals Y over 16. Cool. I can't solve this yet because it's got two variables. Corresponding side to Z is 12. So I got Z over 12. Z over 12. And the corresponding side to 10 is 24. So I wrote all the similarity statements: X over 15, Y over 16, Z over 12, 10 over 24. And now I just, like, I have one that's just a number. So 10 over 24 is the same as 5 over 12. So I can write like any one of, and I can pick any one of these three things here. And just set it equal to 5/12. So I'm going to do x over 15 first. So x over 15 equals 5/12, which means 12x equals 75. So x is 75/12, which is 25/4. Yeah, divide them both by 3, you get 25/4. So that's x. And you can just do the same thing for y and z. And say y over 16 is 5/12. And z over 12 is 5/12. If this is true, then z is clearly equal to 5. Something over 12 equals 5/12. Something must be 5. That's got to be true. Am I doing this right? 5/12? I think that's right. All right, y over 16 equals 5/12. So now I do this times this. So I get 12y equals 80. So y is 80/12. Divide them both by 4 and you get 20/3. So I got x is 25/4. Y is 20/3. And z is 5. It feels good. I'll expect this one to be the biggest, and it is, but not by much. Yeah, this is 6 1/4, not 6 2/3. So anyways, the point here was just to write the similarity statements with the sides, which we did. We had to assume which sides were similar, but I feel safe assuming that I did that right. So we will do a bunch of practice with this in class. So looking forward to that. Bye, guys.